Week 2, June 29th to July 5th. New NEW 13 systems. Moving on with substitution. These you will have an equation or two that are not solved for a variable. Let's go. Again, number 1, practicing that just very basic substitution. We have y equals, got to pick my pen first, y equals negative 3x minus 2. We have x equals negative 1 that we're substituting. So, knowing that, here is our equation, as simple as it sounds. Here's our equation that has been solved for a letter, right? X equals negative 1. Here is what we're taking out. So when I say we're taking out, we are writing this as a template without that letter there, without that variable there. What we're then doing is we are plugging in the other side to it. So we put it in there, y equals negative 3 times negative 1 minus 2, and then we evaluate. So we have y equals negative 3 times negative 1 is positive 3 minus 2. We get y equals 1. So our ordered pair solution is negative 1, positive 1, and we are done. Now, solving this by substitution, state the ordered pair solution. That's going to be the general set of directions for most of these when they tell you how they want it done, and stating the ordered pair solution is going to always be how they want the solution for a system, because a system in two variables, you are going to have an ordered pair because you're going to have an x and a y as your answer. For substitution, we need to get one of the variables by itself. It does not matter if it's a y, it does not matter if it's an x. You do not need to have it in slope-intercept form, okay? You are going to ultimately have the choice on what you are solving or what you are isolating, which variable you are getting alone. The easiest variable to get alone is going to be the one without a coefficient by it. So in this problem, I'm either looking at that one or that one, the y's. Now, given that the first one is a positive y, the second one is a negative y. If I look at a negative y, ultimately I'm going to have to turn it positive, which adds in an extra step. So that's going to knock it out for me. If you want to do it, you do you. But for me, I'm looking at keeping things as simple as I can. So, ultimately, there's many, many, many ways to do all of these problems. So, for me, I'm always going to err on the side of doing these in the way that eliminates the most steps I can, and keeping it as simple as I can. So I'm going to go with the one that has the positive y, because in order to isolate it, all I have to do after I draw my line down the equal sign is subtract 2x from both sides. Once I do that, my 2x's zero out. I get y equals 4 minus 2x. I have now isolated y, and I'm ready to go. So y is alone, which means that now I can substitute it into the other one, into the other equation. Remember from the previous worksheet or previous video that means I can take the other side of it, this 4 minus 2x, and I can put it into the other equation where the y is. So whatever variable you have by itself, that's the one you're taking out of the other equation, okay? So I'm going to rewrite the other equation as a template, missing the variable that you got alone. So 2x minus a big set of parentheses equals 0. What am I going to put in that big set of parentheses? I'm going to put in 4 minus 2x. Now what does that do? Well, now I have to distribute. What am I distributing? I'm distributing that negative because the negative is out in front of that parentheses. So I have to distribute it out. So I end up with 2x minus 4 and then plus 2x because minus times negative 2 or a negative times a negative 2x gives me positive 2x equals 0. Now, combining like terms, I have 2x and another 2x. That gives me 4x minus 4 equals 0. And that gives me 4x equals 4. Now I skipped a little step there. I had to add 4 to both sides. That gives me 4x equals 4. I divide both sides by 4, and I get x equals 1. So when I put that in my ordered pair, that goes in the first spot. Okay, and now I have to go back and plug this in. Now, I have a bunch of choices, but ultimately I want to plug this back into one of my original problems because anything else, and I'm really dealing with human error. So I'm going to go back and plug this all the way back in to my original problem. So 2 times 1 plus y equals 4. So 2 plus y equals 4. I'm going to subtract 2 on both sides, and I'm going to get y equals 2. Okay, I'm going to plug that in for y, and I'm going to get 1, 2. So my answer to this question is 1, 2. All right, let's look at number 3. Again, I'm looking for a variable that doesn't have a coefficient. So the only variable here that doesn't have a coefficient is that one. The second equation, x. So now I need to solve it to get x by itself. So getting that by itself, moving everything away from that x, I am going to add 2y to both sides. Now, just like when I was solving for y, notice that when I add 2y to both sides, I don't add it directly below that negative 3. I scoot it out, okay, because when I scoot it out, they're not like terms on the right side. So they zero out on the left. I bring down that x, and I get x equals negative 3 plus 2y. So now I have an equation where my x is all by itself, and I have this piece that I can substitute in. So I'm substituting for x in my other equation. And what am I substituting in? What am I putting in? Well, I'm putting in this negative 3 plus 2y. and I'm plugging in to the x in that 3x minus 5y equals negative 9. Because again, I need to get rid of those double variables. I can't solve an equation with two variables. I need to turn it into one variable. So I'm going to rewrite that equation, and I'm going to take the x out, and I'm going to rewrite it with a big set of parentheses. And when I do that, what am I going to plug into those parentheses? I'm going to plug in negative 3 plus 2y. Now I'm going to distribute the 3, and I'm going to get negative 9 plus 6y minus 5y equals 9. I'm going to draw my line. I'm going to combine my like terms. So I have negative 9 plus y, just 1, equals 9. I'm going to add 9 to both sides, and I'm going to get y equals 18. I'm going to set up my ordered pair for the end. So y is 18. Y is the second piece of my ordered pair. And now I need to plug 18 into one of these. It really doesn't matter which one you pick. I'm going to pick the second one. And maybe I'm going to pick it because the second one, just because there's an x and there's no coefficient on it. So I have x minus 2 times 18 equals negative 3. X minus 36 equals negative 3. I'm going to add 36 to both sides. And I get x equals 33. That goes here. That went there. And I get 33, 18. And I'm all done. If you plug any of these ordered pairs back into both equations, they will work for both equations, unless I mess something up. But they should work for both equations, because unlike the ones we were doing a couple videos ago, where we were like, no, it's not an equation because when we plug it in, it's not working for both of them. Okay, these we've gotten that they are a solution to our system, right? They do work for both of these. All right, let's look at number 4. Again, similarly to number 3, there is only one variable here, the y, in the second equation, that it's all by its lonesome with no coefficient. So this is the one that we want to get by itself. This is the one we want to solve for. And we've had lots of practice getting y alone. So I want to subtract the 3x from both sides. We don't have to really worry about turning it into y equals mx plus b, putting it in slope-intercept form. We really just have to worry about getting the y by itself. So we can leave the right side as 4 minus 3x, and we're done. Now, this being y equals 4 minus 3x, we know since the y is alone, in the first equation, that's where we're plugging it. We're plugging it into the y. So we're going to bring this over here and we're going to put it in here, because this is what's alone. So we're going to rewrite this first equation as a template with a big old set of parentheses with the y taken out, waiting to accept what y is equal to. And when we plug it in, it's going to be 4 minus 3x. And now all our y's are gone. Now it's a whole bunch of x's. Now we're going to distribute the 2. And we're going to get 5x plus 8 minus 6x equals 5. We're going to combine our like terms, and we're going to get negative x plus 8 equals 5. We're going to subtract 8 from both sides. We're going to get negative x equals negative 3. We're going to divide both sides by negative 1, and we're going to get x equals 3. That's going to go here in our spot for x of our ordered pair. And we have to plug this back into one of them. I'm going to choose the second, again, because that's where we have that lonesome y with no coefficient. And we get 3 times 3 plus y equals 4. 9 plus y equals 4. Subtract 9 from both sides, and we get y equals negative 5. Plug that up here. And that's our ordered pair, 3 comma negative 5. And we are done. Let me know if you have questions. If you get stuck, make sure you go back to the previous video, practice those first where they're already solved for it. Get the hang of substituting it in before you add in the extra step of solving for the variable before you are substituting it in. Let me know if you have questions, and I will try to help out where I can. Talk to you soon.